Hi everyone, I'm back and still alive and kicking just about, more or less. I hope you are all well. Please introduce yourself in the comments, do say hello, and I will introduce you. I'm looking particularly pasty today. I think I've turned the colour off a bit here. Let's have a look at that. Oh, there we go, Just so I don't look too much like a ghost. We've got the idea of back in the old days, and then into the future with some sunshine. There we go. Right, I hope all is well. So we've got not long to go. Today, it's quite an interesting one today, because we're going to look at how you make algorithms. And I know for a few of you, that is the big concern. Hi, Decent, how are you doing? Well done, old boy. Thank you for being here. So let's have a look at this, and I will throw some questions at you and see if you can figure out the answers to these. So stand by. Nice, easy one. Just a bit of a loosener. Just to get your brains working. Hello, Hayden. How are you doing? Let me get hold of you there. An Audi Quattro. Interesting. It was is that the reason that I actually had to end up owning an Audi A4? Because the Audi Quattro was the most exciting rally car in the world. I think it's an Audi Quattro. They won, when I was your age, they won absolutely everything. They won every rally. Just before that, it was the Lancia Delta, which was very exciting, the Integrale. Hello, Paul Burner, how are you? Handsome as ever, I see. I hope you are well. So what about this one? This one should be dead easy. Is it best from Group B? Okay, yeah. Good looking car. My Audi A4 is a Quattro. It's quite an old one, but it was finally came into its own when it was snowy and icy, and it was actually quite nice to drive. What have we got? Ishak, hello dear man, how are you? I hope all is well. So we're looking at a count-controlled loop here. So obviously they're going to want you to A, recognise what one is, and B, use one. Whether you start it from 0 or from 1 probably doesn't matter, but 0 is what you should do. Rukshan, how are you, dear man? Thank you for being here. Outstanding. So this is something which is in the specification. They have never asked it. Well, it does print that first is the answer, Decent. So working this right is that this one's a bit different because Sanuka, how are you, dear man? Hello. Thank you for being here. So this is the most difficult thing they can do for the count-controlled loop, is that they can, first of all, make you count backwards rather than counting forwards. And the step makes it go in, rather than just going 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, you're doing it in steps of 3. Ooh, so Hayden has put this down. And that is the right answer, okay? So that is exactly what we're looking for. So let's work this one through, okay? Let me get my special rectangle. So I equals 10 to 1. So the first part here is that it's going to work. The program's going to count from 10 to 0. Sorry, I can't read. From 10 to 0. But it's going to do it in steps of -3. So it's going to start at 10. So when it prints I the first time, it's going to print 10. Then it's going to take 3 off it. 10 minus 3 is... Oh, Ishak's got it as well. Look at that. You see, just like Ishak has got here. And the second time, it's going to print 7. Then it's going to go around again. It's going to take off 3, and that will give you 4. And then finally, it will print 1, because that's 4 minus 1 is 3. And don't forget that this thing is going to finish at 0. So that's why it's not going to then go -3, -6, or whatever, because you've asked it to stop at 0. You could ask it to stop at a minus number if you wanted to. So hopefully that makes sense, okay? That's not something that's been in the specification forever, but they've never thrown a question at you like that. But the only thing that's really different here is the fact you've got the step and that it's counting backwards. But when you think about it, you can count backwards or count forwards. But that's not been there. So that's the first one. Let's push on to this one. Okay, it's 10741. That was the answer, okay? 10741, which you both got. In fact, Hayden got it right. Decent got it right as well. And so did Ishak. Okay, good. Yes, Decent's doing very well today. We're very, very proud of him. So right, here is the next one. Have a crack at this. This is a bit like the one that I sent my my 2 classes home with today. You know, that past paper from 2018, paper 2. Patience is the key thing with these, and what you don't need to do is hold all of this information inside your head. So if you need to write things in the margin when you've got to go around and check things, ooh, we've got some very fast answers here. We've got Rukshan, who has said 6. We have got Hayden, who said 6. Rukshan was the first. Hello, Jelly, how you doing? Thank you for coming. I'll give you a welcome. I'm not sure that's quite appropriate, but anyway, thanks for coming. It's great to have you here. So we've got 6. We've got Ishak has said. We've got Jelly who said 6. We've got Ishak has said 6. We've got Deason who said 6, which would suggest that you are all absolutely correct. I applaud you. Right, let's push on. So far so good. The step 1 was something a bit different. They never used it, so maybe they'll use it this year. All right, what about this one? This one is a bit more complicated, and this is one where possibly writing down the answers in the... So this says identify the fourth value computable output, the computable output. It might help you to write down what the values of A, B, and C are with each iteration. And don't forget that once this loop happens, so you see at the start of this loop, right, the values of A and B are set. And Ishak was asked me a question about the 666. No, it's not 666. That would be quite concerning. Well, maybe that's, but I, all right, this is a good question, and I'll come back to my Ishak thing in a minute. The I could be any, it could be any number, but the I stands for iteration, right? Iteration. And so this is going to iterate, repeat. So you know, if you're making software like FIFA, each year they have a new iteration of the software, a new version of it. So it's how many times it goes round. So iteration is that's the meaning, right? So this line here means that it's going to happen for the first time, the second time, the third time, the fourth time, the fifth time, until it gets to the 15th time, and then it stops, right? But initially, let's get rid of this. Initially, the values of these variables is set. Okay, they declare the value, but then this bit here is the one that repeats. So this is where it goes round in a circle. Let me be dangerous and try and draw this. So once you get down to here, you then go back up, he says. Try not to knock his mug of tea over. It goes back up to it. Well, effectively, now let's just get rid of that. Effectively, that's not right. It goes back up to here. Okay. So let's see what kind of answers we've got. So does that make sense? The point I'm trying to make, probably quite badly, is that this is the bit of code that actually repeats here. And it repeats 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 15. Okay? So we've got a few different answers coming out here. And my recommendation to you, this is interesting because you're all having a go at it, and we've got a range of answers. I think... yeah, now, by the way, you've reminded me of something quite interesting on this, Paul Berner, is that these questions are actually quite easy, and the temptation is to try to work it out, or to work the whole thing out inside your head. With each iteration, maybe just make a note in the margin of what things are worth, because it's so easy to mess up. It's a bit like doing binary, you know, the binary addition and the conversions and stuff. It's easy, and you guys are all good mathematicians, but doing it inside your head is dangerous because it's quite easy to make a mistake. Can you run through algorithm bit by bit, please? Yeah, I can do that. It took a while. I love this. Hayden goes 2. My final answer is 2. It took a while. Yes, this is the part of your brain where you've got to use your logic part of your brain, where you're thinking quite slowly. This isn't something that just comes to you like this. You've got to actually sit there and focus on it. And the maths isn't hard, but it's a bit of a conundrum, isn't it? So let's have a look at this, right? Is that this is going to run 15 times, but the question has asked you up here, identify the fourth value, the computable output. So this is when it does the print, okay? So I'll go through it the first time, and then I will leave you to work it out for the rest of the times. So we've got the idea that in the first place, you've got A set to 0 and you've got B set to 1, okay? So the first thing it'll do is print A. Well, A has been set to 0 the first time. But then it's doing some funky business here, is that C is A plus B. So A plus B is going to be 1. And then A equals B, so it's 1. And then B equals C, which was 1. So at that point, you can hold that much inside your head, write down what A, B, and C are, take a big deep breath, and then go round and do it for the second time. And then when you've done all of that several times, and maybe it's worth having a look at that, but the answer is 2. So Hayden was the man. His final answer was 2. Can I go back one step, and maybe you guys who are looking at this and going, wow, this makes no sense, maybe get your phones out and just take a picture of that, all right, and make a mental note that the final answer is 2. And this is something that's probably worth spending 5 minutes going through, and it is frustrating. But if one of these comes in the exam, they often ask you 2, 3, or 4 questions about this. Okay, Jelly. So what I'm going to ask you to do is I'm going to have a go at this, and then tomorrow speak to me, and I can go through this in class with you. Okay. Okay. The first thing it prints out is 0. Keep going. Well, the thing is, I've got about 4 or 5 of these to do. Then it's 1, then it's 1, then it's 2. That is, you can't see this. This is Hayden's one here, because I only went through the first one where it was 0, okay? But then with each iteration, the next one is 1, the next one is 1, and then the next one is 2, which is the 4th one. Jelly, and those of you, Ishak, having a look at this, spend like 5 or 6 minutes running through this in your head. It's frustrating, but you will see how you will get to that final result, okay? It's the Fibonacci, that's exactly what it is. So give that a go. It's frustrating, but that little bit of frustration will give you the confidence, because, good. The difficulty is holding the blinking value of A, B, and C in your head and then going around and doing it 4 times. That's what the challenge is, really. So write it down. It just takes a bit of time, doesn't it? This is one of those things that you can't just look at and go, okay, you actually need to work through the algorithm, and it requires patience, the sort of patience that we don't use very often, because we're used to things being snappy, snappy, snappy. Okay, so have a look at that, and if you're struggling with it, come and grab me and I can run through it again. Right, so I thought, first of all, where are we? What time is it? 18:42. I don't intend banging on much past 6 o'clock, because you're all busy. These words on the screen, ideally, you should know what they mean. Yes, yes, yes. That is exactly it. It's the fact that it's set to 1 and then it repeats another 2 times. That's exactly it, okay? That is outstanding. And now listen, a few bits of naming convention here. Part of what can make doing these algorithms confusing is that they call things, they give them funny names. Well, they're not funny names, but they give them names that you don't know. So understanding what things are called, you've got to deal with that, okay? So anything on here that you don't understand, make a note of it and learn it, because that way, if they use these phrases in the exam, you'll know what's going on. So first of all, that past paper we went through today, they had this, and they love this question. What's a variable? And there could be 1 or 2 marks for it. It's a name storage location. The value may change as the program runs, compared to a constant, which, by the way, if they ask you to declare a constant, you know, you'd say x equals 5 to declare x as a variable and make its value 5. All you'd write is const x5 to make it, for it to be a constant, which means the constant won't change as the program runs. But you've got to put in this bit about as the program runs, because obviously when you're writing the code, you can change it to whatever you like. It's only about when the program's running. So that's your constant there, won't change. A construct, so if they ask you, I can't get across there, let's try again. Whoop. If they ask you about constructs, they will be trying to get you to think about iteration selection, okay? Iteration, selection, and sequence. Sequence is the idea that program code starts at line 1 and runs through until the end of it, unless you use one of these constructs, iteration, the while loop, for example, or selection, if, to alter the flow of the program, to change the flow of the program. So rather than line 4 to line 5, it might take it line 4 to line 10, or it might take it line 4 to line 1. So that's what these constructs that you learn do, okay? All right, parameters. We looked at functions and subroutines. Parameters are the values that are passed. Arguments are the values that are passed to each parameter. And then you've got an array, which is a list. And we looked at lists, certainly in my class, just before I vanished at the end of last term. Concatenation is when you join two strings together. So say, for example, if we had Hayden Muggeridge, you'd use the plus to join those two strings together, and then you can join them together. It's called concatenation. Fancy name. Declaration is defining a data type, a variable. An assignment is giving a value. So x equals 5, you are assigning a value to a data type. Initialization, if they ask you to initialize a variable, so if you said x equals 0, you're setting the value of x to 0, and that's called initialization. So setting its value to 0 is called initialization. These are all things that are obvious, but if you don't know what they're called and they start talking about initialization in the exam, it gets really confusing, okay? All right, algorithm practice. Now, you would have seen a variation of this question before. So we're now talking paper 2, section B, where you have to use pseudocode. So up until in section 2, part A, you can just use English to answer it if you so wish. Or you can use flowcharts. People always think flowcharts are easier but manage to mess them up, so be wary of flowcharts. Flowcharts are okay for a fairly simple problem, but for a more challenging one, doing a flowchart actually takes a lot of time, so just bear that in mind. It's probably easier just to write pseudocode. Ask Hayden, he'll tell you. Flowcharts are a pain in the neck to write, especially when the code gets complex. So here's the question. Dreamville is a theatre aimed at children and adults. Tickets are sold online. Adult tickets cost $19.99, kids tickets $8.99. A booking fee of $2.50 is added to all orders. So £2.50 gets added to each order. A function, they want you to write a function. A function ticket price, and that is, you see ticket price here, that is part of the code you need to write when you're declaring a function. What's a function? It's a reusable piece of code that you can call when you want it, and it saves rewriting the code numerous times across your program. Yeah, I had asked Decent to stop barking, but it's a bit of a habit. It's actually Decent does a very good goose noise, I discovered to my cost last term. A function ticket price takes the number of adult tickets and the number of child tickets as parameters. So in other words, and this is important, right? It takes the number of child tickets as parameters. So there'll be a number. So the parameter could be 6, and that means there'll be 6 child tickets. It calculates and returns the total price, so this here. And it's asked you to use pseudocode. Section 2, Section B, Paper 2, you'll be writing pseudocode, okay, to create an algorithm for the function ticket pricing, making you write a function, all right? So listen, this is the process that you need to go through. The first one is abstraction. So abstraction, and they love a question on abstraction. What is abstraction? It's removing unnecessary details. The tube map, where they've taken away the road names, they've taken away any geographical details, they've made all the distances between the tube stops identical. That's an example of abstraction, okay? So abstraction for this problem would be this, and I've crossed out all the guff that you don't need. This looks like a long question. OCR absolutely love to make these questions ridiculously long. So you've got to go through it, and I recommend take your pen and just draw around the bits that you actually need to do, or cross out the rest. It's probably easier to draw around the things you want to do because there's so much guff. So it doesn't matter about Dreamville being a theatre company aimed at children and adults. That's just like a sort of opener. Tickets are sold online. Well, clearly. Adults cost 20 quid, kids $8.99. Booking fee $2.50 to all orders. So you need to calculate the number of adults, number of kids, so there can be different variables for them. And then for each order, you add 2.5 quid, okay? That's it. A function ticket price takes the number of adults and children. So you want a function that takes in adults and children. It calculates and returns the total price to be paid. So you've got to do, if you've got 5 adults, it'll be 5 times, what is it, 19.99. 4 kids, 4 times 8.99. You want to put those together, and then you want to add 2.5 quid, which is the booking fee. Although, Yeah, I mean, seriously, Hayden, the people often find the difficulty with these questions, that OCR, and they'll weave their name into it and say, OCR Industries, they always do this. And their questions go on and on and on and on and on. And the answer is, someone asked me a good question here, decent. A function returns a value to the main program, a procedure doesn't. That's another one marker they like to ask you. So people say to me, well, hang on, they both produce an answer, so what's the difference? The difference is a function will feed the answer back into the main program, and the main program will then use that to go and do something else. Whereas a procedure might just give you an answer on screen, it'll print it on screen. So it might be the answer is boom, but then you'll go off and do something else. That won't get used subsequently. I mean, frankly, you could use a function for either. And they're far more likely to get you to write a function than they say, yes, you would, you'd say return. I'm going to get to that in a second, as it's a version of print. Yes, it is. And the only difference is that with a function, you're then going to go on and maybe use it to do something else. So it'll then be used to then calculate something else. You've got it, like if you need the area of a shape and then you want to use it to go and work out something else, you need to have that saved as a variable and use a function for that. So is return is the answer to get it back into the main program. These are all excellent questions. So this is me having done my abstraction, removing all the necessary rubbish we don't need. And we've got adult 20 quid, child 9 quid, booking fee 2.5 quid, create a function. The parameters, the things you're going to take in, are the number of adults and number of children. So that's going to need to be entered into the program. Calculate total price, return total price. And when you see it written out like this, you're actually looking at the mark scheme. So this bit here, this will be worth a mark. This will be worth a mark, taking in the parameters. Calculate total price will be worth a mark. They usually give a mark for attempting to calculate the total price and a mark for getting it right, and then returning it back to the main program with the word return will also get you a mark. So maybe 5 or 6 marker for this one. So a bit of planning. The actual code you need for it is really, really easy. Am I doing time-wise? 52, okay. Let's move on. So decomposition, breaking it into smaller tasks. So what do you need to do? Make a function. Now this making a function means thinking about the shell of a function. What's the code that you need? If you're Hayden, if you're decent, you might just write it in, hello Bear, how are you? I didn't know you were here, dear man. Excellent. Write it in, you can write it in pseudocode or write it in any language you like actually, but Python, but just stick to one or the other. The differences are pretty subtle, to be honest with you. So then you've got to create a function, then you need to do your parameters, take in the adult and number of adults, number of kids, then you need to calculate the total price and return the total price, all right? So we've kind of done that one. So then computational thinking means you need to turn it into an algorithm. This is the computational thinking. So step 1, make a function. Yeah, you could do all sorts of things to really mess up the examiners and make them put them into meltdown. Fortrans, they wouldn't like that at all. All right, so the function shell, make the inputs, think about the inputs, think about the variables, think about the stuff that's going to happen, the processing, the constructs you're going to use and the outputs. And by the way, this 6 points, these 6 bullet points here, especially 2, 3, 4, 5, 6, this is going to be the same for every single blinking question you do when it comes to creating algorithms. You've got a mark for the inputs, a mark for the outputs, a mark for choosing the right construct. Have you chosen if, or have you chosen while, or have you chosen for? Whichever loop you're going to choose. Get the outputs right, and then if you get it right, you get your final marks. Even those of you that find this bamboozlingly hard, if you look through enough of the past papers that I've given you the mark scheme, you will see that they are all exactly the same. All you've got to do is that bit of decoding to work out where you're going to plug in your different answers, okay? Right, so phase 1, this is the function shell. So guess what? You write the word, stand by, function. And at the end of it, you write end function. So far, that's pretty straightforward. So how does the program know it's a function? Because you've written function. How does it know the function has ended? Because you've written end function. And then all you've got to do is to give the function a name. So we could call this function theatre or function theatre price. And then the parameters, do you remember, that's what we're taking in, number of adult and number of child tickets. And then in here, we write the programming code. That's where we stick our maths. And return is the word we use because it's a function to return it back to the main program. And then whatever we've called our result, that'll be a return plus the name of the variable. So far, so good. Pretty straightforward, isn't it? Well, it is. It is when you think about it in the cold light of day. All right, it is exactly what it needs to be. Right, function shell. Let's push on. Come on. All right. So the function shell. I've said function ticket price. That's what I've called it. You can call it anything. The inputs are going to be, the parameters are going to be number of adults. Good question, Jelly, because it is a word. So let me try and explain it this way, right? It's best explained by way of an example, right? So parameters is the data you're taking into the function. So for example, and it did, right? If we go back to the question here, because it varies. Let's just go back a couple of steps to this one. Bear with me a second. Dun, 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 dun. Back to here. And it says, okay, can you see this bit here? Let me highlight this bit here. Right here, right. Takes the number of adult tickets, so the number of adult tickets, 5 adults, 4 adults, 3 adults, and the number of child tickets, 3, 2, or 1, whatever it is, as parameters. So in this case, the parameters, what's being drawn into the program to then be messed around with, are the number of tickets. Because if you think about it, in this case, the cost of the child tickets is set. We know it's $8.99. The cost of the adult tickets is $19.99. We know that, so we can set that up in there. We can create a variable for the cost of the adult tickets, a variable for the cost of the adult tickets. What we don't know is how many people are going to go, and we know that we're going to add £2.50 to it for the booking fee each time. So we're taking in the thing that we don't know, the thing that on a booking form, you know, when you do the drop down and type number of tickets you want to go and watch a band, this is what's happening behind the scenes. Okay, I hope that makes sense. So it's what you're taking in. It's the number that you're taking in. It's the value that you're dragging into the function. I hope that makes sense. If it doesn't, Jelly, ask me in class and I will give you some more examples, because examples are the way to really understand this, okay? Cool. That is good. But parameters, it's a very Star Trek-y sounding word, isn't it? Okay, so this is how far we got. We've got ticket price and we've got adults and kids. Where are we up to? 57, yeah. Return price. So can you see down here, down here, price is where we're going to store the final cost. So once we've done the, what do we say, $18.99? I forget what the adult cost was now. Was it $19.99? So once we've worked out how many times 19.99s there are, 5 adults, so 5 times 19.99, and we've got 3 kids, 3 times 9.99. Once we've added those together, and then we've added £2.50 for the booking fee, we're then going to store that in a variable called price, and we're going to return that back to the main program. Happy? That's what we're doing. All right. So the whole thing, number of adults, number of kids are going to be inputs, and we need to declare those as variables. So we're going to store all of this information in different variables. So I'm going to call number of adults, or adult. I'm going to call number of children, child, and I'm going to call total cost, price. So all we're doing is we're going to name these things, okay? So these are variables, boxes, and we talked about what variables are. It's a location in memory where you're going to store some data, and it may change as the program runs, okay? So this is what we're doing. For the inputs, you do adults equals input, enter adults. Kids equals input, enter children. So this is what would appear on your screen. It would say enter adults, and you type in 1. So we know it's in inverted commas, that's what appears on the screen. It would print on the screen. Enter children, you enter a number. So you're going to enter 1 and 2, or 2 and 3. And that's what gets dragged in. Those are the parameters that get dragged into the function, and then it does the maths and works out 2 times 19.99 plus 3 times 9.99 plus £2.50, and save that into price, okay? So those are your variables. Sometimes they assume, and this is where I always think back to Hayden, and I was trying to think back to an example quite recently, Hayden, where they made the assumption in the question that the variables had already been declared, that they'd already taken in this information, and you tried to write the program that did far more. So you haven't got, you can assume that you only need to do what they're asking you to do. So if they say that there's a variable that's been collected, you needn't rewrite it. Just take what's on the screen. That's a bit waffly. Let's go on to the next bit. So the maths inside this is the processing. Adults star 1999. So we've got adults. We've taken in adults. That's going to be a number in this variable. However many adults times 1999. Kids times 899. That'll give us the price for kids. So we've got those two stored in two separate variables. We can work those out. Price equals adult plus child plus £2.50. So we're creating a new variable called price. And in that variable, we're going to take the value inside adult, which will be however many, what the cost of the adult tickets are, the cost of the child tickets, and then £2.50 for booking fees. Okay. So that is how it works. So this is what it would look like. Okay. This is what we are after here. Hello, Tiger. Better late than never. Let me just go forward one screen. Yeah, sorry, let's go back one screen. There we go. So this is what you're going to be looking for here, okay? Price equals adult times 19.99 plus child times 8.99 plus £2.50. Return price, okay? And that's it. Pablo, how are you, dear man? Good to see you. Again, if this is something that you're looking at and going, I really don't know, I will put this PDF on Satchel 1 in about 10 minutes and just work through it, okay? But looking back at this question and seeing what this comes out with, every function is just a variation on this. Where are we at? 1902. I'm going to push on. So what about this one? GT app tracks users' average and maximum heartbeat. Users enter average and maximum heartbeat. I'm always thinking, what are they entering? So far, all we need to know is they enter average and maximum heartbeat that's displayed on their fitness watch, something like this. Ta-da! If the average heartbeat is between 0 and 90, ooh, see the word if there, I feel a selection coming on, don't you? A message lazy. So if the average heartbeat is between 0 and 90, then it says lazy. If the average heartbeat is above 90, the message is good. The average heartbeat is 0, and that would be problematic, as we know. If at any point the maximum heartbeat is above 176, the program stops running and displays the message seek medical advice, because 176 is quite high, along with the average and maximum heartbeat of user. So when you look at these, right, don't panic when you read them. Read through it and go, what are they going to ask me to do? Okay, if they're going to do, it'll be a bit of selection in here. And it'll be, if that happens, do that, else do that. Okay, I think we've got this one covered. So let's go through the process again, and I'll do this really quickly. The abstraction. Abstraction is get rid of the junk you don't need. This is saying, if the average users enter the average and maximum heartbeat, that's the first thing. Next we've got selection. If average heartbeat is do that, if it's else, do that. Okay. If at any point the program's above 176, then do this. Now look, the reality is you could actually do everything with selection, but they don't necessarily want you to, okay? So this is what it looks like. Users enter an average and maximum heartbeat. I've sort of written out what this would do. If the average heartbeat, this is what we're going to end up with, is greater than 0 and less than 90, print lazy. If average heartbeat is this, print good. Maximum heartbeat bigger than that, then do that. Now you needn't go through this process because this isn't the final pseudocode, but this is the list of tasks that you're going to have to do. And then at the end, print this, print that, and print the other. And you can see how the mark scheme for this is going to work. So let's jump forward and see how you would do this. Decomposition, that's your job list. Input average, input max heartbeats, do comparison, output the correct message, and print them, and print a message if maximum is 176. So let's think again. Inputs, variables, processing, construct, outputs. This is the mark scheme for every single one that you'll do, okay? Have they got the inputs in? Have they declared the variables? Have they written print at the end? Have they done some processing? Have they multiplied stuff? Have they divided stuff? Okay, they might use mod. Don't forget mod and div as well. Don't forget what they do, and the exponential as well. Okay, to the power of. All right, so the inputs are going to be average heartbeat and max heartbeat. This is what I've called them. Average heartbeat equals AHB, max heartbeat equals MHB. That's what I'm going to call these, just to give them some names. So that's how I would take the input. AHB equals input average heartbeat, MHB, maximum heartbeat input. So that's what appears on screen. So there'll be some numbers put in by the user. It's quite familiar, isn't it? Then let's look at the logical comparison of AHB and MHB. So the comparison of BPM, of beats per minute, is going to be selection. We're going to use an if statement. Now this bit here, I don't know whether you can remember, I know in my class you did this quite recently. Do you remember that that voting, the voting booth one, where if you had to write an algorithm where if you want to vote for candidate A, press A. If you want to vote for candidate B, press B. If you want to vote for candidate press C. But if at any time anyone types end, then this happens, okay? And that's where you'd use the while loop. So that's to make things stop, all right? So in this instance, they want you to use an if statement and they want you to use the while loop, which are, once you've done those two, all that's left is the for loop. And you can use the while loop for anything that's condition controlled, okay? So we're going to use, for the if, we're going to say if average heartbeat is greater than 0 and less than 90, then print lazy, else AHB greater than 90, then print good. And that's it. Okay, so that's what we're going to use for the selection, for the if statement. And don't forget, the other flavor of the if statement is the case select. Just have a look back at the spec to make it's actually easy to write case get case select, but just make sure you're aware of it. It's just another variation of selection, and the only reason people use it is because if you've got lots and lots and lots and lots of conditions, it's much easier to write. Writing embedded if statements becomes quite painful after a while. So while MHB is less than 176, end while. So this is what's going to bring the program to a close, and you're going to top and tail. This will go at the start, and it will at the start of the program, and it will bring the whole thing to an end, because that's when someone has either has been working out way too hard, and you need to call 999. All right. So this will be the while construct. So this is what you're going to use to make the program stop if the heartbeat's over 176. So you've got while and end while. Notice that the while and end while is at the very top and very bottom of the of the program. Okay, and then inside it, you've put this selection here. And you might think, God, it's a bit complicated, but if you break it down and work it out bit by bit, and you think, okay, I need to do a while loop, and I need to do an if loop, I need to do some selection. If you break it down, it's actually quite straightforward. So that while loop is going to trigger the program stopping and saying, call the doctor because you're a lunatic, you've been working out too hard, all right? Although at your age, you probably can be at 176. If it was for me, it would be fairly terminal. Print AHB, print MHB, these are the outputs. Again, you get a mark for each of these. So even if you're looking at one part of it and thinking, I don't know how to solve that, solve everything else. Because if you don't do one part of it, you can still get 4 or 5 marks out of a 6-mark question, all right? So don't get disheartened by it. Do the bits that you can do. And if you can't do all of it, you'll still get some credit for it. So this is what the final thing would look like. I've been going for 40 minutes. I'm aware this is your time. First of all, I've taken in my inputs here, okay? I've taken in my inputs like so. So someone's put in the average and the maximum heartbeat, and I've got those stored inside AHB and MHB. I've then got my while loop, which is here and ends here. And notice how all of these loops, if, end if, while, end while. It's not hard. So this is going to make the program stop. So I've top and tailed my program with this construct, okay? And then inside that, we've got the if loop, because the while loop's the most important one, the one that's going to stop it if the person's been working out like crazy and has been overdoing it. And then we've got our comparison in there, if, and then we've got else, and then we've got our end if there, all right? So those are our conditions in there, all right? That is it. I will send you this, PDF, and you can have a go at it. A question for you. What is the difference between a procedure and a function? My Earl Grey tea has got cold, which is not very nice. What's the difference between a... Oh! We've got Tiger. Tiger may have arrived late, but Tiger is absolutely on the ball. Yeah, function returns. Yes, function returns, function returns, function returns. You are all outstanding. I didn't play my quiz time jingle. I think it's so insane you deserve to hear it. Function returns a value to the main program and a procedure doesn't. You are all outstanding. What about this one? What construct do you use when you don't know how many times the block of code should repeat or loop? Which construct? Yeah, it's better than what. Which construct do you use when you know how many times? When you know how many times a block of code should loop? Which construct is that? I can see all the answers are coming through. They come in a bit slowly. Okay, so I've got... Okay, so we've got Decent with 4. We've got Hayden with 4. We've got Tiger with while, Gamble, Ishak with 4, 4, 4, and 4. And it is 4 because 4 is the count-controlled loop. So if you know how many times... So if it says it's going to happen 10 times or 15 times or count down from 10 to 3, you know that from the outset. You know the for loop. So quite simply, if you're struggling with the difference between the for loop and the while loop, I think, Tiger, that is very generous of you. And I think that really is, I'm going to applaud you for your generosity, because it is fair to give these children a chance in life. If you know how many times, use a for loop. And if it's not selection, then it has to be a while loop. It's literally one of 3, okay? So just by process of elimination, you can figure it out. Okay, write a loop that prints out a countdown from 100 to 0. I've lost the ability to read quite clearly, but thankfully you can. So rather than me waffling, that's what I want. So can you write a loop and write it in the comment boxes, everybody? Can you write a loop that prints a countdown from 100 to 0 in 5s? So in other words, it'll go 100, 95, 90, and it will stop when it gets to 0. Ooh, Tiger, you are on fire. Hopefully not like Shere Khan. That was a very rough ending for Jungle Book for him. So that's what Tiger's gone for. For I equals 100 to 0, step minus 5. Oh, look at these people. They're all good. Ishak is good. I didn't give you a ding, Tiger. There we go. I'm very sorry. And there's one for you as well. Hayden is that. Geez, Tiger. I think he's impressed. So that's what we've got here. For I equals 100 to 0, step 5. Decent, you got there as well. They will give you a mark for recognising it's a 4. They might give you a mark for getting the maths right, such as it is. And they might give you, Ishak won't let you forget that, and they might give you a mark for doing the printing as well. So how easy is that? Have a look at that for loop. That's what it always looks like, okay? You can go backwards or forwards, and it can be in steps, and whatever you choose the steps to be. You are all still here, and we're there! Ta-da! Okay, 45 minutes, that's pretty good. So I will, as soon as I've hung up, I sound like an old man, as soon as I've stopped doing this, I will put the PDF on Satchel 1 for you. The bits that are making you a bit confused, have a look at them. And if you are still finding it hard, come and talk to me and I'll go through them, okay? So guys, you are absolutely... So we've had 27 in today, which is very impressive. A lot of lurkers, but that's fine. Lurk and pick up what you can. Half watch me, that's fine. Guys, have a lovely rest of the evening. I will see you all tomorrow and we'll do the same thing next week. Okay, take care. Bye-bye, guys. Be good, be good.